So let's go over a couple more examples of how to do area between the curve. So if we got find the area of the region bounded by y equal x squared minus 4 and y equal 4 minus e raised to the x plus 1, and it's calculator active. So the first thing you want to do is graph this and find your intersection points. So we're going to graph x squared minus 4, and we're going to graph 4 minus e raised to the x plus 1. So the blue graph is the x squared minus 4, and the red graph is the y equal 4 minus e x plus 1. So we want our two intersecting points because they're going to be our lower bound and our upper bound. So we're going to use our intersecting feature. And one of them is going to be 0.957677703. And you don't want to round off until the final answer, so you want to use that entire figure. And so then we're going to get the other intersecting. And we're going to move up here. And so our other one is negative 2.799025. So that's going to be our lower bound, and the other one's going to be our upper bound. Now, while we're looking at this graph, you can see that the red graph, which is the 4 minus e raised to the x plus 1, is above the blue graph through the entire region. So the part that we're going to be looking to find the area of is right in between there. So now we're going to use our Math 9 feature. And I don't want it in that screen, I want it in a plain screen. So Math 9. In our lower bound, we're going to put negative 2.799025. If I could type tonight. Okay, let's try that one more time. Negative 2.799025. And make sure I got it right. Negative 2.799025. And then I'm going to go to my upper bound. And I'm going to put 0.95767703. And we're going to do our parentheses 4 minus, pull up your e, x plus 1. And I'm going to close that off in parentheses, and then minus, and then I'm going to do another parentheses, x squared minus 4. So you can see how I'm doing this. So I've got the top curve first and the bottom curve second. And I'm going to come over here and do d of x and hit enter. And that is the correct area. And you'll round to 3 places after the decimal. So you'd write your answer as 15.534. Now let's look at this second example. Find the area of the region between the curve x equal y squared and the curve x equal y plus 6 from 0 to 3. So you notice they're x equal equations and they're y upper and lower bounds. But it's a non-calculator part. So you have to make your table with values to get an idea of what the graph looks like, unless it's an obvious one that you know the shape, because you want to know which one's the right and which one's the left. So over here, I know I'm going from 0 to 3, So I'm going to put 0 in here, and that makes x 0. I'm going to put 1 in for y, makes x 1. I'm going to put 2 in for y, and that makes 4. And I'm going to put 3 in for y, and that makes 9. So over here we're going to do the same thing. We're going to put 0 in, get our x, put 1, get our x, 2, get our x, 3, get our x. And then we're going to rough sketch both of those curves. So if you look at this one and this one, and we're going from 0 to 3. So this is the area. So this is the furthest right. This is left. So when we go to do our integral, then we're going to do 0 to 3, our right curve minus our left curve. And then we're going to integrate using our power rule and evaluate with our fundamental theorem of calculus. And once you do that, you get 13.5 for the area there. So let's try one more where we're going to use our calculator. It says find the area between the x-axis and the curve y equal 2 minus x squared, 0 to 2. So we're going to graph this, and you're going to notice something about the graph. So let's look at the graph. So we're going to graph our 2 minus x squared, and our x-axis will be y equals 0. And we're going to look at that. Okay, and we're going from 0 to 2. So look what happens. 2 is going to be past. So right here, if you're talking about 0 to this point, you're going to have to find this point so that you can talk about that area. And this will be your top curve. But when you come from here to here, if you notice this little area right in here, your red line's going to be on top. So you're going to have to split these up as 2 intervals. So let's find out what the intersection point is. So it's at 1.4142136. So we can use Math 9. So what we're going to do is we're going to do 2 different intervals. We're going from 0 to this point and have our 2 minus x squared. So we're going from 0 to this point, and our 2 minus x squared be top. And then we're going to go from 1.41 to 2, and our 0 line will be on top. So let's look how we do that. So we're going to go Math 9, and we're going from 0 to 1.4142136. And we're going to do 2 minus x squared. And you would do minus 0, but of course that's not going to change, so we'll just do that. And then we're going to put plus, and then we're going to do Math 9. And we're going to go from 1.4142136 to 2. But now we're going to say 0 minus parentheses 2 minus x squared, close parentheses, and then do our dx. So see how we did that? That's the second part because the x-axis was going to be on top. And then over here, I can slide this over so you can see it again. Then here we had this curve on top minus 0, so we didn't have to put it. So if you do and hit enter, you're going to get 2.4379, and you're going to round up to 2.438, which is the correct area.